All right, so this meeting is being recorded. We'll resume our slide deck. So to the left, you'll see these individual squares under the binary column. They represent one bit. So if the value in that is 0, it means false. 1 means true. Example of representing number 8 in binary is 1 followed by like 4 zeros. Is that right? Yeah. Similarly, 65 is 1 followed by like 5 zeros and 1. Lowercase a has a different representation. Uppercase a has a different representation. And if all bits are 1 in 1 byte, it is equivalent of 255 number. Now you'll notice that number 65 and a have same representation, right? So do we see a as a, but computer internally sees that as number 65. That's kind of a visual way of representing it. If you want to see how different alphabets look like, you can search online for ASCII tables, and it'll tell you exactly how a computer sees these alphabets and symbols internally. Now, apart from bit, nibble, byte, and word, there are larger representations of data, like kilobyte is 1024 bytes is 1 kilobyte. Megabyte is 1024 kilobytes, and so on and so forth. So every like kilo, mega, giga, and tera are multiples of tens, following the previous representation. And we all see this very commonly in our day-to-day lives. We talk about GBs and TBs. Going next, can anyone make a guess which city's landscape is this?
Is it Beijing?
LA.
There you
I think
go.
it's Los
There it is.
Angeles, right?
Yeah, I
No,
was
this is,
close, huh?
yeah, Los Angeles. You're right about that. Spot on. So, but this is true for any other downtown or any other place where buildings are. What we see is before buildings exist is just kind of a piece of land, and then engineers come in, they plan the land out, and then they construct building on it. But before constructing building, what do they do is they come to an agreement is what type of building do they want. You just can't go and construct anything and then decide what to do with it. Office spaces are different than homes are different than restaurants, they are different than hotels. So you have to first know what you're doing before you can construct a building. Isn't that true that this is how we actually behave in our day-to-day life? We have to know what we're doing before we can actually finish it.
Yeah, that's true.
So is Java, is you have to know beforehand, and that helps make Java writing better. So as an example in this, the building to the right, its name is Wilshire, and it's a hotel type of building. So you can go and stay there. Similarly, this building, probably Metropolis, is a residential. And definitely residential buildings are different than hotels. The building Aeon Center is of type office. It's people go and work there. Whereas BOA Plaza is a bank, and US Bank Tower is an office. So what we see here is every building has a type. It occupies space, and we name it. We try to name it unique so that we can identify it uniquely. And just imagine the chaos if all buildings had the same name. That's an impossible of a world to live in. So we see that in this example scenario, buildings have a type associated with them, they have a name, and they occupy space. So similarly in Java, entities that store data or reference data are called variables. Definition of variable is A variable is a name associated with a memory location in the computer, right? So same as how buildings have name, and they occupy space on a physical land. Similarly, in computer, data occupies space in the memory, and we give a name to that memory, and that's called the variable. Right? Any questions? All right. Feel free to unmute yourself and ask question if there is any. I hope you all are still seeing my screen. So what is the memory location? It's a continuous sequence of bytes. As we talked about, bytes are bits, so we can break it down into continuous sequence of bits, but then
It's bytes and
mostly
bits or bytes and bots?
it's bytes and bits. But for the sake of consistency, we'll stick with bytes unless stated as bits. So a memory location is a continuous sequence of bytes. And what is memory location used for? It is used to store a value. An example of this is this like a fluorescent yellow, a light yellow rectangle you see is representation of memory, and each individual green box is a sequence of bytes, and they are holding some value in them. As an example, will it rain today? The top left is false. Maybe it will not rain today. What is the day of the month? Is 9. Where is the year stored? Is 2020 is stored somewhere else. So this is how variables, they occupy space in RAM. Now these some variables can change, like constants, value of pi. It doesn't change. So that's a constant. But some variables can change, like today's month, like today's day is like something, maybe 24th, tomorrow will be 25th, and so on and so forth. So this is a quick introduction to variable. It's a name associated with memory location in the computer. Right? So Java defines certain rules about variables. So these are called, let's call it variables must-haves. Right? So what should a variable have? A variable should always have type. Remember, a building has a type. Either the building is of bank type or residential type. The type defines what the purpose of that building is. Similarly, in Java, a variable must have a type. It defines what the variable is going to be used for. Right? We'll come to a more subtle definition of type later on today, but to start with, it gives an idea to the programmer what the variable is supposed to do. Now, there are different types in Java: Boolean, integer, double, bytes, char, short, long, float, etc., etc. But the three types that are part of AP syllabus are Boolean, int, and double. Right? A variable must have a name. Just imagine all these buildings that we saw. If they didn't have any name or unique address, it was impossible world to live in. So a name gives a convenient way for a programmer to access their variables or reference their variables or data in the memory. Example of certain names are is the font color blue, or account balance, or soccer score. So these names are very intuitive. It kind of tells us what they're doing without knowing much about them. Value. A variable must have a value. So there are two types of value. One keeps changing. The other is fixed, like constants. They change. They don't change. And certain things like score, it'll keep changing as the team score more. So as per Java, a variable, there are three must-haves for variables. A variable must have a type, it must have a name, and it must have a value. If it doesn't have any of these are missing, there'll be a problem in program compilation. Moving on to the next. Before this, anyone has a question?
I have a question.
Yes.
What's a Boolean type? Am I saying that right? I saw that
Yes.
back there.
Great. So, well, we'll cover this more as we go further, each type. But to quickly answer your question, Boolean represents either true or false. So it's equivalent of a bit. It can either hold a true value or a false value.
Oh,
Right?
as like a type of the variable, whether it's saying it's true or false.
Correct. As an example, name is the font color blue. Either it is yes, it is blue, or no, it is not blue. Right. So so that becomes like a Boolean type of variable, which can hold only Boolean can hold only true or false. It cannot hold anything else.
Oh, okay.
I have a question.
Yes.
So do variables act differently across different languages?
Do variables? In general, no. But I mean, if you understand variables in one language, you'll be able to get it in any other language because they kind of follow similar syntax. But there could be some subtle differences. As an example, certain languages allow more fine granularity in terms of declaring variables, like C and C++ have something called as a concept of unsigned variables, right? Which means the numbers that they hold cannot be negative. But in Java, there's nothing like unsigned. Well, there is, which is a char, but then it's out of syllabus. Almost every type in Java is signed, which means it can be positive and negative both. So C will have something called as unsigned integer to represent a positive integer, and just like int to represent positive, negative both. But Java just has one int. So you will see that variable declaring of variable is kind of consistent across the board. Modern languages they don't enforce defining a type because they guess automatically, and in that case, they instead of defining a type, you just say auto or some. Let's say JavaScript, you'll say var, or in Python or wherever you don't even have to kind of specify all of that. So as the languages are getting more modern, it is becoming smarter. But at the end of it, whatever data we have can be classified under these different types of variables. Did I answer your question?
Yeah. Thank you.
Yeah. Any more question? All right.
See any questions? Okay.
Move on. So let's look at declaring and initializing a variable in Java. So as we said, a variable must have a type, it must have a name, and it must have a value. And all statements end with a semicolon in Java. So a typical variable declaration would look something like such. It has a type, name, and type could be Boolean, integer, double, and I can have a name and a value, right? This is how we declare and initialize it. Now, what do we mean by initialization? Declaration part is only to the point type name, that's declaration. But when the moment we say is equal to a value, we're initializing the variable with some value to begin with, right? Now let's look at some examples of a Boolean type. Boolean type is a lowercase, and then the way we would initialize, declare and initialize it in Java would be Boolean is light on equal to false, or Boolean train arrived is true. So what we're doing here is we're saying we have a variable is light on and its initial value is false. It starts with a false. Integer would we declare as int, lowercase. Total candies is maybe 90. Cars is 144. So now our variable starts with a predefined number, and maybe who knows, going forward it'll change. A double is also lowercase type. Account balance. pi. So this is how we declare a variable and we initialize it with a value. Now, in the previous declaration, we saw that we assign a value the moment we declare it. But Java allows another way of doing it is providing initial value is optional. So you can just declare a variable as type name and semicolon. That's it. A type is defined. Example is Boolean is light on. A Boolean train arrived. Integer total candies or cars or account balance and pi. So here we are not assigning any value to these variables. We're just saying reserve a space in the memory and name it account balance. It is of type double. Right? So that's what we are saying. We're not assigning any value to it yet. So when would we use this way of versus initializing it beforehand? Is we may use it in situations when we don't know what value they should hold to begin with. Only later in the program we'll figure out what value they'll come up with. But the condition is we must assign some value to variables declared in such a fashion before we use it. So we can't say get me total candies count unless we add some, like put some value to it. Right? It is clear about it? Any questions?
No, not from me.
Okay.
Oh wait, I have a question.
Yes.
So for like the values, so they would change like after you use different code, right? To like that just adds it and different.
Yes. So so let's say if you want to find out what is the value of is light on, but you declared it without initializing it. Java program will complain that there is no value to is light on yet before you use it. But let's say you declare it as Boolean is light on, and you write your program. But before using is light on, you somewhere write a code which says is light on equal to true, which means now you're assigning it a value, and then it'll just be fine. So you would go ahead with this kind of a declaration when you don't know what the initial value should be, and you will only know about it later in the program. Maybe, let's say, you may find it as a result of doing some math thing, multiplying two numbers. So, yeah. It is advised to always declare a variable with some initial value, but Java won't enforce it.
Okay.
So when you don't declare any initial value, what are default values held by them? A Boolean type default starts with false. Integer starts with 0. A double starts with 0.0. Now,
I have a question.
yes.
So how do you make the variable a default value?
So let's say, let's go back to the slide prior to this. So when you declare a variable in this way, and you can always set a Boolean to false to begin with, like an integer to a 0 or a double to a 0.0. So you can just give them some initial values, and like for Boolean, false is a default. What everyone would expect is you start with false. For integer, you'll start with 0. The reason for doing that is it avoids accidents. Let's say you declare a variable without giving it any initial value, and you start using it in your program. Your program won't compile because it will complain that, hey, you declared a variable, you did not assign a value to it, and now you're using it. You're trying to use something which is not defined yet completely. So the best way to get not have those problems is to always initialize a variable with some default value. It's recommended to have false and 0 and 0 for Boolean int and double, but you can have any initial value. Is that does it answer your question?
Yeah, thank you.
Okay. Moving on, Java types. A type in Java translates to memory size. What do we mean by this, right? So when we say a Boolean, it can store only true or false, which is 0 or 1. So its size technically should be 1 bit, right? But in Java, Boolean size is not well defined. So I'll just leave it as undefined for the sake of one-on-one correspondence with what it can do. We'll assume it to be 1 bit. Whereas an integer, it is 4 bit. So the moment we say integer candy count, what we are telling the Java compiler is, in the memory, reserve 4 bytes for me and name it candy count. So whenever in my program I say candy count, I mean this, 4 bytes in memory for you to go and refer. So integer is 4 bytes, which means it is 32 bits, and it has a range of minus 2 raised to 31 to 2 raised to 31 minus 1. Are you all familiar with binary math? Like how it comes to 2 raised to 31 or any of that?
Oh, just exponents?
Yeah, like
Yeah.
okay. So okay. All right. So there it is. That's the maximum range of integer that it can hold. So if your number, so what happens if your number exceeds that 2 billion count? Any guesses?
I guess it'll just like cut out or something, or say like error.
That's a good guess. Any more guesses? Very close guess.
It might crash. It might say like maybe it's too big for it to handle.
Okay, so see the upper range is 2,147,483,647. What happens if that 647 becomes 648? We add 1 to it. One guess is it'll error out. Any other guesses?
One person says it'll overflow.
Okay, and then what will happen if it overflows?
Zane? Back to start, he says.
But Zane doesn't have a mic, so
Ah, okay.
Okay, yeah, that's actually very right. This is what happens is it'll just start over. If we add 1 to the maximum range, then the result will be 0, surprisingly. We'll see that in one of our sample programs. It's a very fun experiment to do. Double is 64 bits, which is 8 bytes. So when we say, when we tell Java that, declare a variable double, name it pi, then Java immediately knows that you need 8 bytes of memory location and you want to call it as pi. So whatever value you assign to pi, Java is going to store it in those 8 bytes. And as this is 64 bits, it has a much bigger range than integer. It's literally like twice. So when we have integer, why do we need double for? Is it only just because we need bigger range? Only because we need to store something more than 2 billion? Or maybe 3 billion, that's why we need double? Maybe not. So the reason when we need double is when we have fractions in our results. So let's say 3.14, we'll need double, right? Because integer cannot store floating point. we need integer because Boolean cannot store anything beyond 1. So there are other data types to store bigger integer values, but we'll just stick to our curriculum. So double is used when we have fractions that we need to store. A double can have 15 significant decimal digits. So that's good enough for most of the assignments. Any questions so far? All right, going next. Let's look at under the hood. What happens when we declare a Boolean valid train and set it to false? So in the RAM, Java will allocate you 1 bit and it will set it as false and it will name it as valid train. So when you say, whenever you access valid train, you're actually accessing that piece of memory in your computer without even knowing about it. How about Boolean is awake equal to true? So look at the flow here, how Java internally does it. Is in memory somewhere, it could be anywhere in the memory. It'll allocate a bit for you and it'll mark it as false. It'll name it as is awake and it'll set its value to true because that's what you want is awake true. So whatever is assigned to a variable is updated in the memory. Similarly, day of month, it'll just allocate 4 bytes in the memory, give it a name, and so on and so forth. Now, observe the pi. It says final. Well, I think there's a mistake on the slide. The pi should have been 3.142, and it should have been a double. But the point here is to note it's final, which means whatever value you assign to pi, it will not change. What will happen if you try to change a value of a final? Like if it is a constant and you try to change it, what do you think would happen? Any guesses?
One person said error message, 2 of them say error message.
Yeah, you're right. During compile time, Java will find out that, oh, you're trying to assign a value, like you're trying to change a value of a pi or of a final, and it won't let you do that. It'll not even compile. So a constant or a final can be assigned a value one time. That's it. Types of variables. So we'll go over them again. Variable types in Java. 2 types. There are many types. The 2 that we are concerned about, they fall into 2 categories: primitive and reference. Right. Now, primitive types there are 2 types of primitive: Boolean and numeric. So obviously, Boolean is Boolean type, but rest all types are numeric that we have seen so far. Under numeric, either they can be integers, which is plus minus whole numbers, or they can be floating point, plus minus, right? Now, when they are whole numbers, they can be of type byte, short, int, long, and char type, right? So, but what we'll be sticking to is int type. Now, these different types, it's good to know about it is because we all know integer is 4 bytes. A byte type is 1 byte. A short is 2 bytes. A long is 8 bytes, and char is 2 bytes in Java. So it's good to know, but we'll be mostly considering and sticking to integer. Similarly, in floating point, there are 2 types: float and double. Double is 8 bytes, float is 4 bytes. And both hold floating point numbers. So as an example, even though long is a bigger memory, which falls under integer, than float, which is under floating point, yet long cannot hold floating point numbers. Its structure is different. The reference type. So what are reference types? Let's tackle that first. So primitive types are the basic fundamental data types supported in Java, but reference types are composite. I mean, they are not fundamental. They are constructed using primitive, more than one of them, and they are all wrapped to act as a new type. So those are called reference types. Those are classes, interfaces, enumerations, and arrays. So we'll come to them later in the coursework, but this is just for reference. And apart from primitive and reference types, there are more types in Java: null, void, union, wildcard, interface, unknown, and var. It is just for information purposes. You can read about it if it interests you. All right, question answer time. Everyone ready?
Yeah, I'm ready.
Awesome. So the question is, what type of variable should you use to represent the average grade of a course?
Zane says char.
Okay.
Edward says double.
Okay. Any more options? Suggestions?
One clarification, do you mean letter grades?
That's a good one, actually. I should have put that in the question. No, I meant non-letter grades. And well, in that case, double is the right answer. And why is it right answer? Any guesses? Why should, if it is a non-letter grade, it's an average grade. So in that case, why should we use double? Why not use integer? Boolean for that matter.
It's integer. Decimal, Sam says decimal.
Yeah, that's right. So the moment there's decimal, we use double. If it was not a decimal, we could have used integer. Next question. Represent the number of people in a household. What variable would you use? What type of variable do you use to represent number of people in a household?
Everybody says integer.
That's right, integer, because it's hard to have fractions in there, right? We all are
Well,
whole.
we can have 2 adults and 1 baby. It cannot be 2.1.
No. Question number 3: to record if it is raining or not, what data type would you use?
Boolean, they say.
You guys are pretty smart. You should have had tough questions. Boolean, right? Because whether it is raining or not raining, either it is raining or it is not raining, right? Including drizzling could be considered raining. So we know it's either true or false, Boolean. How about, okay, this is the last one. Type of variable used to represent the amount of money in an account. Any guesses?
Double.
The easy one, double. Why double? Because it has fraction. Do you guys know that mostly we deal with only 2 decimal places when it comes to money, but businesses can have more than 2 decimal places. So you can pay someone less than 1 cent. It's pretty interesting. All right, moving on. Naming variables, right? So there are certain rules that we need to follow when we name variables. Now, not all of these rules are enforced by Java language, but it is most widely adopted. So everyone would expect a Java programmer to name their variables in a certain way, including the AP exam, paper checkers or whatever they are, because they are going to look at so many programs and they have no patience. They may not have time to follow through, your variable throughout your program, they would just make a guess of what your variable is doing by looking at how you have named it. So you have to make sure that you name your variable very relevant. So let's look at what are general recommendations for naming variables in Java. So variable name should start with an alphabet. You cannot have a variable name starting with a number. It has to start with an alphabet. Reserved keywords cannot be used as variable names. So you cannot have variable names as for, if, class, static, int, double, etc. So there's a bigger list of reserved keywords in Java, and you cannot use that. The moment you do that, your compiler is going to complain, hey, I don't understand what you're trying to do here. Name that defines the purpose. Example, score, temperature, grade. These type of names are very intuitive. A score would be used for keeping score of something. You can be more specific, like score, soccer score, or anything else. But temperature, as an example, is everyone knows what temperature is, and you can't. If you use temperature for referencing something else, that will not be right. So name your variables to define its purpose, what exactly it is doing. Try to have the name as short as and precise as possible without losing the meaning. There's no point in writing, coming up with names bigger than absolutely required, because it makes it hard to write and also read. Be short, precise. Variable name must always start with lowercase. So remove the first rule. It says variable name should start with alphabet. That's like a rule from Java. But this one here, which says variable must always start with lowercase, is the Java language doesn't enforce that. It is only for it's a standard practice that every Java programmer follows, is they start their variable names lowercase. Use camel case for naming variables. What is a camel case, right? So camel casing is, let's say you have a word, school name, right? 2 words, school name. So your first word will start with lowercase, but all subsequent words will start with uppercase. So as an example, if you want to represent a variable, name a variable to hold a school name, you'll say school name with lowercase s and uppercase n. That's camel case, and that is different from school name with uppercase s and lowercase n, or all lowercases, school underscore name, all combinations of it. So those are not camel casing. In camel casing, only the first alphabet of the first word is lowercase, and every other alphabet of other words are uppercase. It's like, so that's like a common rule of practice here. Use all uppercase for naming constants. So if your variable does not change its value, then you have to make sure that it stands out. Else people may accidentally try to change the value and things won't work, and they'll be confused what happened. So a very common practice to distinguish such variables whose values never change is to completely declare them in uppercase. So they stand out and you exactly know this is some kind of a constant. Example is pi in all uppercases. School name. Now here you can add an underscore to separate out 2 words, make it very easy to read. So camel case for variables that can change, all uppercase for variables that don't change. And the last one is avoid using random and funny names. It confuses people and not applicable in AP exam. Like this is a long name, or I just want to declare a variable, or integer x, integer y. Those are kind of very difficult to follow through because their purpose is not defined. What are they doing? Who knows, unless you go through the program. And in AP exam, they could not be acceptable. Any questions on naming variables? For students who have prior experience in programming, did you follow certain kind of naming conventions in there? Do you want to share some of that?
I have a yes.
Go ahead.
Zane?
Again, he doesn't have a mic, so he might just type it in chat.
Okay.
Okay.
Like if you were going to do is it raining, you would do is raining, is is
Yeah.
starts with lowercase, and then raining R is uppercase. That's camel case.
Yeah. That's right. All right. Anything else?
Very good, Reese.
Yeah.
I hope, like I said, you guys are taking notes, right?
Yes.
Very good.
All right. So let's quiz time, right? Why not? So naming variables. So what is camel case variable name for a variable that represents shirt size?
Edward says shirt size and camel case with the S uppercase for size.
Okay. Awesome. That's right. It's so intuitive. If you read that in a program, you exactly know this is going to give you a shirt size. What is camel case variable name for a variable that represents if it is raining? Well, I think they just got answered. So let's get that. Is raining is right. What is camel case variable name for a variable that represents top score?
Let's score S uppercase.
Top score.
Mm-hmm.
Okay, that's right. What is variable name? Well, here's the answer for variable that represents seconds in an hour. Is going to be all uppercase, is because we know that there's 3,600 seconds in 1 hour. And I think that S is, I don't know why it is still there. It should have been taken away. But the idea here is it's a constant, so we would have it all uppercase.
I have a question.
Yes.
So we only use this kind of naming because it's like general knowledge that it should be. So like that's for organization, right?
This is for organization. Yes. This is what like almost every Java programmer uses. So to be in par with it, meet the expectations, and the subtle reason is generally programs are written once and they are read multiple times. So there's enhancement in your program. There's upgrades or adding new functionality. Someone else is going to read your program, right? And they will not understand what you were doing unless a common convention was followed. So in organizations, they have coding standards to make sure that everyone follows the same conventions of naming variables or the way they name classes, functions, methods, and all that. So it's
Let
to make
me add a little bit to that. Human language has grammar, right? Our natural language has grammar. So similarly, your compiler, whoever created the compiler, the engineer, the James Gosling, the author of Java programming language, when they created the compiler, they have to have a set of rules how this language is going to be compiled and executed in the JRE, Java Virtual Machine. So like human language has a set of rules called grammar, the same way programming language also have to have a set of rules, and they are called grammar, but we don't say this here as grammar. But that's what you're learning actually, basically.
Okay.
Syntax. Yay. Zane says syntax. Awesome. Syntax. Syntax.
Yeah, that's right. It's a syntax. All right, moving on. Any more question?
Cinemax. Okay, very funny.
Moving to the next section. I think this is as important as it is to learn how to write Java variables and write Java code. Is to how to comment your code. So code comments are inline. Example is, you just write one line statement. It always starts with 2 forward slashes. Another way to add comment to your code is multi-line. You may have more things to write, and in that case, it starts with a forward slash and one asterisk, and ends with asterisk and a backward slash. And then here's an example, right? So there's a method. It adds 2 integers. Now, a lot of times people use one of the 2 ways of inline commenting. To the right of int sum, you will realize there's a inline comment. That's one way of doing it. The other way is right below it. There's an inline comment which says add both parameters, and then we do a sum equal to a plus b. Both are acceptable ways of commenting your code. And of course, at the very top of the method, there's a more detailed description of about what your method is doing. So why do we need to write comments? Is, as I stated, code is written once and read multiple times. In every one of our lifetimes, we'll write so many programs, and we'll keep writing new programs. Someone else is going to continue working on things that we no more work on. So they need to understand what we did when we wrote our program. What was the idea? What was the logic? So these comments help a lot. That's one. Secondly, Java docs is a source of truth for how to write good comments in your code. And there are tools. If everyone follows the same rule, same set of rules, then you can make tools, and then those tools can automatically extract these comments from your code and make documents for you. So if you want to give your program to someone else, like sell your program to someone else for money or use, and they want to know what you have done so that they can modify it, you want to give them some set of documents, and of course well documented source code, right? And that concludes our presentation for today. Now let's look at a sample program to so everyone, what we should do is open your IDE and let's you all can see this, right? So I've written this code for everyone, and let's open our IDEs and get ready to write this and run it on our computer. Let me open my IDE.
Can you make it bigger? Font the doc that you showed with the code.
Yeah, we all will write it together. So
okay.
Right.
Is there anyone that is not able to do this in your IDE IntelliJ?
So open IntelliJ, and I think if you saved your IntelliJ from last time, you would still have hello world.java in there. If you don't have it, then just right click, new Java class.
Good. Keep it going.
Okay. You guys can see my screen, right? Yeah, it's still presenting. Okay.
Yeah, we can. I can see it. Yeah, it looks like. Oh, he wants to zoom it in. There you go. It's better, right? Good.
All right. Zoom in is a problem? No problem. Okay, so let's declare some variables and let's print it out on the screen and see how it goes. Right. So we'll start with the Boolean.
Okay, there's a
So
question. Somebody's getting a message. Okay, somebody's answering it. There's a plugin update, and you can do it later. Yeah,
yeah.
it is good because you don't want anything to reboot.
So let's all declare a Boolean named default Boolean. Right. So we know we can do this is because Java allows us to declare a variable without assigning a value to it, right? So once we do that, let's type system dot out. See the hello world, just the line above. So we'll try to print what value of this default Boolean is, right? Print line, and then we'll say, let's say value of default Boolean in double quotes, and then we just put default Boolean in here, right? If it is everyone getting this red underline in your code? So if you hover your mouse over it, it'll tell you might not have been initialized. So what it's trying to tell you is you declared a variable, but you did not initialize it. So you can't use it. And if you try to compile this code, it's going to throw some exception like errors. It won't compile. So go ahead and compile it. I think one of us don't have the IDE working, right? So in that case, what you should do is right click on the hello world, and then you'll see somewhere it'll say reveal in Finder. It'll open the folder where your Java file is.
By the way, whose ID is not working? Maybe that was Harris. He's not here with us.
Okay, so I hope everyone's ID is working. Now when you have written this, do a save and then go to build. You can also do run. Just go to run and do a run.
Okay, so can you, Prakash, go over these steps, like kind of recap, summarize the sequence? I think a couple of them might benefit from it.
Okay, so we all have a Java project, right? Or do you want to start from?
No, just the steps, just point your,
Okay.
and then say what.
Yeah. So once this is, once you have written that, you can go to Tools menu. Oh, sorry, Run menu of IntelliJ, and then you can either click on Run Hello World, or you can just click on Run. Either one is fine. And the moment you click on it, you'll see an error. It says Java variable default Boolean might not have been initialized. So see how smart IDs are? Is before you run your program, it starts underlining, oh, this is a problem here, making it very easy to not do mistakes, or making it hard to do mistakes. So what does the error say? Variable blah might not have been initialized. Okay, now when we know what the problem is, let's try to just fix it. It says no initialize, no problem, we'll initialize it. Default boolean, we'll set it as true. Save it. Okay, once you save it, run hello world. There it is, hello world, and then value of default boolean is true, right? Everyone on the same page?
Mine still has an error. Maybe I did something.
It has a yellow underline or red underline?
No, it still has a red.
It's still red?
Mm-hmm.
Can I look at your screen real quick?
Yeah. I did share.
Let me try again.
It says that it's presenting.
Why can
I just saw your screen. What happened?
I have no idea.
Okay, cancel it and then start over.
Yeah, we can see it. I can see it.
Okay.
I can't see it.
Click on his presentation against his name that says presenting or presentation. Oh, somebody's breathing.
Somebody just let out a deep sigh.
Deep sigh of relief.
I still can't.
Prakash, you click on his name under people, and Parashar, where within parentheses
Okay.
it says presentation. Click on that pin.
Yes, now I can see.
Yeah. Okay.
Technical glitch.
Yeah. Okay. So can you rerun the program?
Because in your system, you have lowercase system. It's uppercase system.
Oh, okay. That's it. Okay.
That's it.
There's still a red line. Is that okay?
Because you have set default boolean equal to true, but when you declare that at the top, you have not defined the type. So the compiler doesn't know what default boolean is.
Okay, so
what you have done is you have assigned a value before declaring it. So in the next line you say default boolean is boolean, but you're trying to assign it. So what is happening is your Java program, it comes down to the main, it prints hello world, and it is looking at default boolean, and it's not understanding what is that. Right?
And one person is asking, what does the yellow underline mean?
Yellow underline, if you hover the mouse over it, it'll tell you. It means the ID is trying to tell you that the value of this boolean is always true. Is that what you want?
Edward is concurring. Yellow line is warning, like your traffic lights.
So in your case, here in the screen, just delete that line. The true,
this line?
you're trying to assign a value to a variable which is not declared yet. So the computer doesn't know it's a variable unless it sees default boolean.
So it has to be under here.
Yeah, it has to be under there.
So is it default? Is it just this equals true?
Yeah.
Okay.
And then semicolon. Everything ends in Java with a semicolon. All right, now run it. There it is. And we have success.
Yeah. Zane, just run it and see what happens. That's the best way. This process that you're going through is called debugging, troubleshooting, and debugging, which is a very important process. Awesome. Yep, that's good.
Okay. So I'll take back your powers.
Parashar, you can stop presenting.
Yeah. Mm-hmm.
All right. So back to the screen here. You all can see my screen, right?
Yes, I can. Yeah.
Okay. So first thing first, yellow line is a warning. It's not a showstopper. The ID is trying to make you careful of the fact that default Boolean is always going to be true. And in this case, it doesn't matter because we're just printing it out. But when you're writing more complex programs, it could happen that your variable is always set to a true, and then if you do if, else, while, and all those things, more complex logic, then it will not behave the way you would expect it. Now, what Parashar was doing is something we should know about. It's a very interesting use case, a scenario he ran into. Is what he was doing is he was assigning default Boolean as true, and that gave him a problem. And why was that a problem? Is because when the program starts running, or when the compiler actually, in this case, tries to compile a program, it sees hello world, it's happy with it, goes to next line, and it says default Boolean is true. But what is default Boolean? It doesn't know about it yet. So it'll just stop there and it'll say, I don't know what default Boolean is. See, it says cannot resolve symbol, default Boolean. The only time it would know what default Boolean is when it comes to the next line, where we say default Boolean is of type Boolean, and then it may know, but that's going to happen later. So at this point in time, compiler doesn't know, it's going to complain. So that was going on there, but we fix it. Now, let's do one more real quick. We'll do an integer. Let's say we call it score, and we'll give it 10. So now there's a different way of declaring a variable. We declare a variable and we also initialize it with a number. So we can do a system.out.println value, or in fact, in this case, we can just say score is double quotes and then plus score. Hit save and run your program. And it runs, right? The score is 10 in this case. Now, we didn't have to assign a value to score again because we started with declaring it and have an initial value to it. So in this case, there is no compilation error; it just works fine. So that's what I was trying to refer to is when you don't, as an example, if I delete this line which says default true, there's one line. If I delete that, we have a problem here. Our code won't compile because we missed to assign a value. But if you would have declared it with a default value, so I'll put this line. Let's say default value would have been false, right? And then, but we want it to be true. We can later always go back and set it to true, and then that will get rid of the nasty red line that we get in our code. Do you guys follow what I did? Is we can always start with a default value and change it if we want it, right? All right, any questions so far?
Looks like they are gold.
Okay, we'll do one more real quick, and then we'll jump into something interesting that we'll use next time and build upon it. So let's call it double. Let's call it pi is equal to, how do you want to do it? 22 by 7. This is how you prefer your pi to be? Or do you want to just do 3.142? Either is fine. Let's just stick with 3.142, right? And then do a system dot out dot println. Println is print line, right? So in this case, okay, there's one more way of doing it. So everyone do system dot out dot, just do print. And if you just stop at print, you'll see there are a bunch of options. There's a string, double, char array, and all that. It is just telling you Java can handle, Java print can handle so many different types of variables. In our case, it's going to be string, but you can choose anything. It'll auto resolve. Zain, yeah, we'll come to it. I got your point. What Zain is saying is, should this not be final because it's not going to change? Yes, it should be final, and we'll do that just in a bit. But let's run this one experiment. So let's say value of pi is, and that's in double quote, and then just write pi. Save it. Once you are done, run the program. And all right, so value of pi is 3.142, right? Now what happens is I can go ahead and do pi is equal to 22 by 7, right? Do that, and then I can copy that line, paste it here. So I'll say new value of pi is all right. So there are two things that I want all of you to look at. Is first of all, we declared pi, we gave it a value, and we changed the value of it. And as rightly pointed, that pi is something which is constant. So when that's the case, Zain, thanks for pointing that out. As programmers, we don't want anyone to change the value of pi, right? Else you don't know how the program is going to behave. So if you want to restrict people from changing value of pi, you can do a final double, and the moment you add the word final to it, there's a red underline under the next statement. Cannot assign a value to final variable. Do you all see that? So the moment you do final, the compiler won't allow you to change its value. So there are less chances of accident here, right? Whenever you access pi, you always know it's going to be 3.142, right? Now the second thing I would like to like you to look at is in the output, you'll see if you have used print instead of println, you will realize that value of pi is immediately followed by new value of pi, right? Whereas if you look everything above it, they are all printed neatly in new lines. So why did that happen? That happened is because we used print. Print just takes whatever we give it and puts it on the console. Whereas println is it prints a new line. So it'll take the content, it'll print it in a new line. So that's why in every other prints, we did not have, like, everything came in new line, whereas the last two were kind of concatenated, right? So now as our pi is final, we'll just comment the line out, or you can delete it, doesn't matter. You can comment this out. You can run your program, which should run just fine. right? So that's a quick example of what we learned today: declaring variables. Boolean is 1 bit, integer is 4 bytes, double is 8 bytes. Double is used to store floating point numbers, fractions, whereas integer is used to store whole numbers, uh, positive, negative. Let's do this one more fun exercise. Copy, and let's declare one more integer, right? Let's declare an integer. Let's call it int. What should we call it? Int. Quotient. Let's call it QO for now, and then we'll assign it, let's say, 2 divided by 3, right? So we know that that's not a whole number. That's not a right example. Let's do 3 divided by 2. Any guesses on what will happen here? If we do a system.out.print, what will be the value of QO?
Will it say an error?
Error. Any other guesses? All right, let's try it out. We'll figure out what's going to happen now. So, question is, before I run my program, what results do you guys get? Zain says round to 3. All right, we'll figure out. Let me know what results you guys get. Anyone?
Oh wait, do you want us to say it?
Yeah, say it or write it down.
It said 1.
Okay.
1.
Did anyone else get any other result? Maybe says reach end of.
The reach end of file?
How did that happen? Sam?
I don't know if it's related, but it just says Java reached end of file while parsing.
So maybe at the end of your last line of your program, just hit 1 enter and then run it again and see that solves the problem. So at the very end, where the end brackets close.
On your screen, you have 2 brackets at the end. I only have 1.
Or maybe that's why. So let me zoom out so you can see how it looks
Where does
on.
that start?
So right after main, there's 1 bracket. So your bracket either could be that way or it must be just very close, sticking close to main. But it should be right after main.
All right, yeah, thanks. I see it now.
Okay. All right, so let's run the program. Voila. Well, it mixed it with pi, right? Because I used print here. So I'll do print line. Run it again so that it is all neat. Okay, question is 1. Why is it 1? We know 3 divided by 2 is 1.5. That's because integer cannot handle fraction. So it just drops everything after the decimal notation. That's why it's left with 1. Right? Now, I think it's we are out of time. So before we end our session today, let's quickly do one thing which we couldn't do last time, is to accept user input, right? So far, we write numbers in the program and we're printing it. What fun is that? How about receiving it from the user and doing something with it? So in that case, we will have to tell Java that wait for user to input something, right? Now, the way Java receives all that information is typically in string. So Java will wait for the user to type something, and then it'll give your program the string that the user typed in. The user could type number, could type anything, but they all will come to you as a string, which is a different data type. We'll not talk about it a lot, but we'll just use it for now to get a hang of it. So everyone just write a string user input, right? And then we can just leave it as is, or we can just have a double quote, which means it's an empty string, right? And then before you write anything else, go all the way to the top of your Java file. See, everyone sees public class hello world, nothing beyond that, right? There's nothing, that's the first line, right?
Mm-hmm.
Now observe this when you write scanner. So scanner is an API, a library that Java provides for taking user inputs. We'll call it input scanner is equal to, we create a new scanner. Don't worry about it if you don't understand what's happening. It's good to know. We'll cover this later on. System.in. What we are doing is, remember system.out, we were saying whatever the output of a system is, go there and print this value. It could be console, it could be anything. Similarly, we are saying whatever is the input for the system, use that to accept user input. Now, once we have that, now we'll ask the Java program to receive input from the user. So the user input, and when the Java program receives the user input, what it should do, it should assign it to user input. So the way to get this is input scanner dot get line. Did that not work?
My scanner is red. It's in red. Is that okay?
Scanner is red. So click on scanner.
Yeah, I have it clicked.
And does it say?
It says java.util.scanner alt alt enter.
Yeah, alt enter. So what is happening here is, now if you observe above your class, you'll see a new line which says import Java util scanner, right? So this is what I was trying to point towards, is when you use a library in your program, you're supposed to import it. Else, let's say when Java program starts compiling your code, it'll go through all of that and it'll come to scanner and it'll be like, what is scanner? I don't know. So you tell Java that first import library scanner. So when Java does that, it knows what scanner is. And when it'll come down here, it'll be like, oh yeah, I know this, right? So all right, let's just do next line, right? So we're telling Java that whatever user is going to input, get me that, and we'll print it out. System.out.println user input was in quotes and user input. Hope this works. Keeping my fingers crossed. It'll work. And let's run the Java program. There it is. It printed quotient 1, and then the program is still running. Actually, there's a better way to tell user about it. But now enter something. Enter a name. My name is Prakash, so I just enter Prakash. There it is. It's a user input was Prakash, right? So this is a way to receive input from user. We'll use it as we go further in the program lessons. Next session we'll have more hands-on programming using whatever we have learned so far. Right? We'll use these variables in different ways. We'll maybe also receive input from user and use that. Any questions?
Yeah, mine doesn't have that. I mean, mine doesn't. When I run it, it doesn't say the.
So let's do it in a clean way. Before getting the user input, which is this line here, let's tell user that the user is supposed to enter something. So system.out.print, because if user doesn't know, we may think the program has ended, but actually it's waiting. Enter something, right? And then let's rerun the program. There it is. Now the computer is waiting for the user to enter something. At least it could be something more intuitive message, but it's good enough. Do you guys see that happening? Now enter something.
Yeah, it works.
So yeah. Right, so we learned about how to receive inputs from user. We learned about what variables are, what are different sizes of variables. We learned about how to declare and initialize variables. Right. So
I would like to check on Haley, Nate, and Sam. How are you doing? Sam's good. Haley's good. Okay. Nate. Okay.
so I think that's it for today. Next time we'll have a lot of programming. So practice until then.
All right. Okay. Anyway, so the video in the background, I'm not sure, but thanks everybody. By the way, if you have questions, send an email to MX Irvine. I'm typing that.
Yeah, and I'll be on call for 5 more minutes, just in case if you have any questions and you want to ask it, feel free to do that.
Yeah. All right. Very good. Thank you, Prakash. Anybody else before we drop off the call? All right. Good.
All right.
You are welcome to tune out, and we'll see you next Wednesday. Oh, by the way, the Friday and Saturday class, Unity and C# that Fernando is teaching is another awesome class. If you're going to be in software and programming, and you need to consider joining those classes. And Fernando, he enjoys teaching that class. Okay. Hopefully, we'll see some of you in that class Friday and Saturday, 3 o'clock. Friday, 3 o'clock, and Saturday, 10 o'clock in the morning. Take care. So long. Bye.
Bye.
Bye, everyone.
Bye, Prakash.
Bye, Fernando. Yeah, good night.
Yeah, same.
Bye.
Oh, yeah, if you can send me the what are you gonna do next week?
Yeah, I'll send you in an email. How about that?
Yeah, awesome. Thank you, man.
All right.
Peace. Bye.
Take care. Bye.